Here's some more problems from section 3.7. We're asked to find the second derivative of y with respect to x. Actually, also, and along the way, we will also find out what dy dx is. So let's take the first derivative. If I take the derivative with respect to x of both sides of the equation, I'm going to get 2x plus 2y dy dx is equal to 0, or that 2y dy dx is equal to negative 2x, or dy dx is equal to negative 2x over 2y, or negative x over y. Now, if I want to find the second derivative, I'm going to take the derivative of both sides of that with respect to x. Right? And when I do that, I'm going to get the second derivative of y with respect to x. And here I'm going to get a quotient rule. So I'm going to get bottom times the derivative of the top minus the top times the derivative of the bottom. And the derivative of y is dy dx. And then we're going to divide that whole thing by the bottom squared. Let's see if we can do a little cleanup on that. I get plus x. And remember, I know what dy dx is. It is that. So I'm going to multiply x times negative x over y. And then this whole thing is divided by y squared. Let's see if we do a little bit more cleanup. We end up here with negative y minus x squared over y, and that's all over y squared. Common denominator for the top is going to be y, so I end up with negative y squared over y minus x squared over y. And then I'm going to take that and I'm going to multiply by the reciprocal of x squared, or multiply by 1 over y squared. What do I end up with? I end up with negative y minus negative x all over y cubed. Okay, now if we clean up just a little bit more, we can get to the book answer. I can take the negative sign out here and get x squared plus y squared over y cubed. But hey, we know what x squared plus y squared from our very initial equation. It's equal to 1, so we can replace that with a 1 and end up with negative 1 over y cubed. All right, and there's problem number 27.